This video is going to go over the fractions homework that you were given on the first day of class, and I want to use this opportunity to work out some problems and make sure everybody can access the videos online. So I am just going to work out each problem step by step and show you my thought process. And I'm going to use a slightly different method than the one shown in the other video, the 6-minute video of solving complex fractions, so you can choose the method that you're used to. In problem number 1, I've got x plus 3 over 2x, all of that divided by 1 minus y over x. So before I can use my division property where I multiply by the reciprocal, I need to get this bottom expression as one set of factors. So I'm going to use my addition and subtraction rules and get a common denominator. So right now I see that I've got a 1 and an x, so my common denominator is going to be x. So I'm going to achieve that by multiplying the first term by x over x. And what that's going to do for me, it's not going to change the top at all, but here on the bottom I'm going to have x times 1 is x minus y, all of that over my common denominator, which is x. Now I have one expression divided by another expression, so I am going to, and it looks like I've copied the problem wrong. It looks like instead of a y right here, this is a 7, so that's even better. We have one less variable. So now I'm going to take my top expression, and to divide it by the bottom I need to multiply by the reciprocal. And so this is how I show that, and then I'm going to do what I grew up calling cross-canceling. I'm going to check on my diagonals of my multiplication expression and see if there's anything that could be canceled out. And I can't really cancel anything inside of an addition or a subtraction expression. Each of those is one whole factor and they don't match. But here I've got a 2x and an x, so I'm going to just cancel those x's. So if I multiply across on my numerators, I get x plus 3. Multiply across on my denominators, I have a 2 here times x minus 7. And this is going to be my final answer. In problem number 2, let me just copy the original. Got x plus 3 over x minus 5, all of that over 1 over x plus 2 plus 1. And so again, I'm going to follow the same pattern as the problem on the top. I've got a nice, neat expression here, but down here on the bottom where I've got an addition, that's going to be an issue for when I want to divide. So I want to combine this into one expression by getting a common denominator. So x plus 2 is my denominator, so I'm just going to multiply this expression by x plus 2 over x plus 2. So that gives me 1 over x plus 2 plus x plus 2 over x plus 2. And the top is going to stay the same for a while. And let me just go ahead and work with this bottom expression again. So now that I've got common denominators, the rule of fraction addition is you keep the denominator and add the numerator. So 1 plus x plus 2 is simply x plus 3. So now I can rewrite my large fraction as, so it's a division problem, so now I want to rewrite it as a multiplication where I multiply by the reciprocal. So I'm going to take the bottom expression, x plus 2, and make that my numerator. X plus 3 is my denominator. So right now my way of learning would be to cross cancel. Some of you might not be used to that, so you might want to come across, multiply everything out, and then do your canceling. I think just getting rid of it from the beginning just saves me from a little bit of writing. So my final answer is x plus 2 over x minus 5. Problem number 3, x minus 4 over 15 in a complex fraction with x over 5 plus x over 10. And so, again, before I can do my division, where I divide and multiply by the reciprocal, I've got to get this addition problem all as one expression. So I want to get a common denominator so I can do my addition. And I look at my denominators of 5 and 10, and I can see 5 goes into 10 2 times. So if I multiply this expression by 2 over 2, that's going to give me 2x over 10 plus x over 10 in the denominator, which I'm just going to combine like terms, 3x over 10, and now I am ready to use my division process, which is take the numerator, flip the reciprocal, and multiply it by the denominator. So I am going to go ahead and cross cancel where I possibly can. Now, many of you would be tempted to look at these x's and try to do some sort of cancellation. But remember, we only cancel things that are factors. So 3x is a factor. The whole thing, x minus 4, is a factor. So unless you see another x minus 4 somewhere, you can't really touch this. But where I'd like to cancel is here with my 10 and my 15. They have a common factor of 5. So I say 5 goes into 10 2 times, 5 goes into 15 3 times, giving me x minus 4 times 2, or I'll rewrite it like 2 times x minus 4 on the top. And then I've got 3 times 3x, or 9x on the bottom. And number 4, 2x minus 3 over x plus 2 over 7x over x squared minus 4. So those, fortunately, are already simple enough where I can use my division process. So I'm simply going to rewrite this problem, 2x minus 3 over x plus 2 times x squared minus 4 over 7x. Unfortunately, right now I'm not able to simplify this any further unless I see that one of these expressions is able to be factored. So we're going to go over factoring a lot more in our next unit, but so for right now I'm just going to mention this x squared minus 4 is a difference of squares. So I'm going to rewrite everything, but I'm going to show that that factored out is x plus 2 times x minus 2. So anytime I see a quadratic, if I'm doing something that involves simplifying, if I can factor that quadratic, I'm going to be able to get it into a much more simplified form. So now I'm looking on my diagonals for things to simplify, and I see that I have two x plus 2's that will, on top and bottom, that will cancel out. So now I am ready. My final answer is going to be the 2x minus 3 times x minus 2, all of that over 7x. I've already copied down problem number 5, and I am ready to start dividing that out. So I'm going to use my rule of division, which is to multiply by the reciprocal. And did I copy that problem wrong? Yes, I copied that problem wrong. 6 over 3x minus 3. So I'm going to do 3x minus 3 over 6. So I'm already kind of starting to notice that I've got some canceling that can happen here. But as I'm looking at these two expressions, I see that I can use a GCF to factor 3x minus 3. I see that so 20 over x minus 1, 3 is a GCF there. So that's going to help me notice that those x minus 1s on the diagonal can cancel out. So now I'm left with just numbers. There are no variables left in my problem. So I can look at this either as 20 times 3 is 60 over 6 and do that division, or I could have canceled 3/6 and gotten 1/2, and I could have done some other canceling there. But either way, you can see that the answer is 10. So I've copied problem number 6, and it's going to be similar to the others in that I need to get a common denominator on the bottom so that I can add those two expressions. So if I multiply the second term times 2 over 2, I get x plus 2x, which is 3x over 20. Now I'm going to do my division, which is to multiply by the reciprocal. So I can see that my x's cancel. But other than that, I've got 5 times 20 is 100, and then a 3 on the bottom. And that is as far simplified as it can go. Okay, in problem number 7, I've got a numerator that needs to be combined, and my denominator is all there's no addition or subtraction in the numerator or denominator, so I can leave that alone for the time being. So I'm looking at my two denominators here. I've got a 2x and a 5, and I can see that my common denominator is going to have to be 10x. So I'm going to have to multiply by 5 over 5 on the first one and 2x over 2x on the second one. So the reason I'm allowed to multiply by different things throughout the problem is that everything that I'm multiplying by is equal to 1, and I can multiply 1 times anything that I want anytime. So just rewriting things into equivalent fractions. So if I look at the first term, I get a 15 over 10x plus 18x squared over 10x, all of that over 4 over 5x. So now I'm going to use my addition process where I keep the denominator and I add the numerator, so that's 15 plus 18x squared, all over 4 over 5x. So now that I have expression over expression over expression over expression, now I can use my division process, and I'm simply going to rewrite that. I'm going to take my original numerator and my original denominator, and I'm going to multiply by the reciprocal. So now I'm looking on the diagonals for anything that could be canceled, and I can cancel my x. And 5 over 10, 5 goes into 5 once, 5 goes into 10 2 times. So now I have 1 times this whole expression, 15 plus 18x squared. And on the bottom I have 2 times 4, which is 8. And I'm just checking to see how that matches up with my solution, and that matches the answer key. This expression could be factored a little more. I can pull a GCF of 3 out of each term, but it looks like they're not looking for me to go any further, so I'm going to stop there and go on to my last problem, number 8, which does involve a little bit of factoring. So let's get it copied down. 3 over x plus 2 plus x plus 14 over x squared minus 4. All of that over 4 over x squared minus x minus 6. So let's do some simplifying if we can. So in order to know what my GCF here is in the numerator, I'm going to want to see about factoring this expression here in the denominator. So if I simply rewrite that as x plus 2, x minus 2, because I noticed that that was a difference of squares. Now I can see that I've got x plus 2, x minus 2, and then there's this x plus 2 over here. So if I multiply by x minus 2 over x minus 2, that's going to give me this x plus 2, x minus 2 as my common denominator. So that all looks a little bit messy right now, so let me rewrite it as 3 times the quantity x minus 2 over x minus 2, x plus 2, plus x plus 14, and then all of that is over x minus 2, x plus 2, and the order that I write those doesn't really matter. While I am rewriting things, I'm going to go ahead and take a look at my denominator here. This is a quadratic trinomial which can be factored, and I'm still working on how you guys show your factoring, but I am looking for two numbers that when they multiply they equal -6, and when I add them they equal -1. So that is going to be -3 times +2, and then -3 plus 2 equals -1. So that's going to tell me that that thing factors like so. So I'm just going to go ahead and write that appropriately since I'm recopying everything. Okay, so this doesn't look more simplified, but now once I'm ready to add this numerator together, it will become more simplified. So let me go ahead, I'll write my denominator, and then my numerator I'm going to combine. So I'm going to do I'm going to distribute 3x minus 6 and then plus x plus 14, and then there'll be some like terms that I can combine there. And then I'm ready, since I'm dividing by this fraction here, I can multiply by the reciprocal. So before I see some things that I can cancel, but I really want to get this thing combined into some like terms. So 3x plus x, that's going to equal 4x, plus -6 plus 14 is plus 8. And before I go any further, let me just go ahead and factor that out. So the 4 is a GCF, so that'll be x plus 2. Alright, so that's my new numerator over here, so let me rewrite the whole thing. 4 times x plus 2 over x minus 2, x plus 2. And here I've got x minus 3, x plus 2 over 4. So only one of the x plus 2's can cancel. So, oh, but look, we've got a 4 and a 4, so that's nice. So here, I don't think there's anything else that will cancel, leaving me with x minus 3, x plus 2, divided by the quantity x minus 2. And that is a correct final answer.